happy Friday or Saturday or Sunday or whatever day it is when you're watching this. This is going to be for the homework that was assigned on Friday, 10-16. But remember those weird little face brackets that we were using today? I was like, I'll look up what they're called. So they're called braces, curly brackets, or squiggly brackets. Or if you trust Wikipedia, which you really shouldn't, they're called curly brackets, definite brackets, swirly brackets, curly braces, birdie brackets, French brackets, Scottish brackets, squirrely brackets, gull wings. I like that one for some reason. Seagulls, they are not called seagulls. Squiggly brackets, twirly brackets, two-porg brackets, accolades, pointy brackets, second brackets, fancy brackets. Okay, so apparently they have a lot of names. Braces sounds familiar. So does gull wings, though. Just type in. Oh, well, okay. That was unhelpful. Anyways, moving on to the homework. Here it is. So if they give you the braces, I like face brackets better. But if they give you the braces, it means this is all that's on your graph. This is all your points. These are all your values. Nothing else. Just these. Nothing in between. Just these. So this one is a function because every x value they give me is only related to one y value. -7 is only corresponding to y equals 2. 3 is only corresponding to 5. 8 is only corresponding to 4. -6 is only corresponding to 5. Notice that I have two 5 y values. That doesn't matter. Y's can do whatever they want to do. X's have to be exclusive. So that's fine. I can have two of the same y values. And then -2 is only equal to 3. So it is a function. Oh, maybe that won't be as easy as I thought it was going to be. I'm going to try one more time. Yes. Aha! Yes, it is a function. And then the domain, you have to... My bad. I didn't select my typing thing. There we go. My domain, you use the brace, and then you just list all of the x values they give you. So -7. Oh, I'm supposed to do it in order. So my lowest x value is -7. Then my next one is -6. And then my next highest one is -2. And then 3. And then... Okay. So you should still list them from lowest to highest, but you're only listing the x values that they gave you. They're telling you, this is it. There's nothing in between. These are the only points. Nothing in between. All right, so that's my domain. My range, same idea, except I'm going to list all the y values. Oops. So from lowest to highest, the lowest y value is 2, and then 3, and then 4, and then 5. Oh, well, that one was easier. Okay. That's my range. Oops. Brace. Okay, number 2, is it a function? So are my x values only equal to one y value? So let's see, 9 is 2. There's no other x, there's no other 9 for x. So that one checks out. What about 0? Oh no, x is 0, y is 4, x is 0, y is -3. Nope. I have two x values that are 0 and they're equal to different numbers. So no. No. Not a function. My x value is not being exclusive. Why can't I? Why is this so difficult? Nailed it. Okay, no, it's not a function. But domain, same idea as before. They use the braces. So you just, they're not, oh, I clicked the wrong thing. So you just write down all the x values they give you. Boom. So the lowest one I think is 0. Yep, So I have 0. And then I have another 0, but I don't have to write it twice. And then I have 2. Nope. And then I have 3. And then I have 4. X equals 4. And then x equals 5. And then 0, 2, 3, 4, 5, 9. Oh. That's my domain. Range, same thing, except now you're writing down the y values in order. So y is -3. That's my lowest one. Y is -1, -3, -1. And then 0. And then 2. Yes. And then 2. And then 3. Y equals 2. Y equals 3. And then I forget one. Oh, and then 4. Make sure I got it. Is that all of them? Oh, no. Oh, there's a 7 in there. And 7. There we go. Now that's all of them. Okay, so number 3. Whatever. We'll just keep on keeping on. If you understand this, just fast forward me. I'm a video. I won't be offended. No, I won't know, so I won't be offended. So you're looking at all your points. Is it a function? X is 1, y is 2, x is 2, y is 3. Nope, that checks out. Each x value is only equal to one y value, so yes, this is a function. All right, I'm going to do this on my first try. Nope. There we go. Yes, it's a function. Each x value is only equal to one y value. Domain. Once again, they use the braces. So you also use the braces, and now you just rewrite all the x values in order that they give you. I'm tired of analyzing it, so I'm going to look. So it's 1, 2. Oh, they just count all the way up. 3, 4, 5, 6, 7, 8, 9. That's your domain. So you put it like that. There you go. And then your range. That means these are just whole numbers. That's it. Like 1.5, no, not there. No decimals, no fractions, just these whole numbers. Then your range, 2 through 9, 2, 3. You're just going to rewrite the y values they give you in order: 5, 6, 7, 8, 9. Voila. Okay. Determine the domain and range for each of the given functions. We've been doing this a lot because it's important. Domain. Domain, you're looking at the x values. All right. So what is your lowest x value? So I'm looking left to right, side to side. I'm looking side to side. My lowest x value is, ooh. All right, so they split these into 4. So this is, no, they didn't. They split these into half. So this is 1/2. This is 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6. So my first, so this is 1. So it's a filled in circle. It's on my graph. Using, oh, not that. I'm using a bracket. And then it goes on forever that way. So it goes to infinity. Which I don't think I figured out how to do that on here, did I? No, I did not. Okay. Oh, wait, hold on. No, never mind. Okay, so you would write the infinity symbol, but here I'm just going to do infinity. And then when you're dealing with infinity, use a parenthesis. Range. So now we're looking at the lowest y value. The lowest y value is 0. 0. And then we're continuing forever in this direction. Really, it looks like there's, oh, nope, we're just continuing on forever. So 0 to But you would write the infinity symbol, which is a sideways 8. I just don't think I have a way to do that on here. Okay. And you use a parenthesis because you're dealing with infinity. This guy, ooh, fun. Domain of this guy. So we're looking at x values. So my lowest x value is right here, -5. -5. And then we have a continuous line. I'm not picking up my pencil. It's a continuous line until x is equal to 0. Is that 5? Oh, that's 6. -6. Sorry. -6. -6. And then anyway, and then we have a continuous line. I'm not picking up my pencil. Everything in here is covered all the way to x equals 0. All the values are covered between -6 and 0. Okay. But then we have a jump or a break. A jump or a break in our graph, right? There's no graph right here. So that means between 0 and 2, there's nothing. So that is not in my domain. There's nothing there. All right, and then I get to x equals 2, and we start again. So, do I put a comma? No, they don't. So you can put x equals 2. And then, once again, we have a continuous line where I'm not picking up my pencil. Everything, all the decimals and fractions in here are covered. All the x values between 2 and 9, 8. And 8 are covered. So that is your domain. So between 0 and 2, there's nothing. There are no x values. So there is a break in your domain. Range. Oh, range. Okay, y values. So lowest, remember, go low to high. So now we're looking low to high. What's my lowest y value? -3. Okay. Now we're going up. So -3, and I have a continuous line. Everything's covered up until y equals 0. I wonder if I can, hold on. Nope, that's not what I wanted. There we go, a line. So everything from y equals -3 okay. So everything from y equals -3, everything has a point corresponding to it. And then y equals 0, I have a point. And then this one's going up. So for y, everything is covered from y equals -3, all the way up to y equals, +3. Can we just write it right next to it, please? Nope. There, close enough. 3. Okay. So that one, there is a break in the graph, but see how, so there's a break in the x values, but the y values, everything is covered from -3, and then we continue increasing from -3 to 3, everything is covered for the y values. I could draw lines from here to my graph, and everything would be covered. From all the way from y equals -3 to y equals +3. Okay, is that all that was? Yes. Okay, domain and range of this guy. -2x plus 7. Okay, there are no limits on this graph. This is a slope-intercept form equation. The slope is -2. The y-intercept is 7. I can substitute anything in and figure out the y value. I could substitute 5 in for x. -2 times 5 is -10 plus 7 is -3. But I could also substitute fractions in and get a value. So you can substitute anything into this graph, anything in for x, and you would get a corresponding y value that makes sense. Or you get, doesn't even, I should not have had to make sense. You can get a corresponding y value. You can substitute in decimals, which means you can substitute in fractions, you can substitute in negative numbers, whole numbers. You can also always graph it. And so remember, if you're given an equation and they don't tell you that it's discrete, or it doesn't come with a word problem that tells you it's discrete, you always just assume it's continuous, right? So this equation is just going to continue on forever in both directions. I would graph it if there was a good way to graph it on line. Hold on, I'm going to pause and I'm going to figure that out. Okay. Oh. Okay, there we go. So if you were to graph it, so what I would do to graph this is you can substitute in values for x. You could substitute like, okay, x equals 0. So then negative 2 times 0 would just be 0. So your y-intercept is 7, which you should already know by looking at the equation. So that's 7. And then your slope is negative 2. So that means you go, so I go down 2, so 6, 5, and then I go over 1. And then 4, 3, and then over 1. So you're going down 2 each time. Or you can switch it and go up 2, over 1. Or backwards 1. Yeah, up 2 and backwards 1. Anyway, so this is your line. It is a function. Oh, we didn't have to answer that. Domain, that's what we're answering. Well, my function is going to continue forever this way, and it's continuing forever this way. There are no limitations on it. So my domain, let me go back to that, is just going to be negative infinity to infinity. Hold on. Move me over there. There we go. So then your domain. Oh, that's not. Okay. Negative infinity sign, which I don't have on here. Oh, to infinity sign that I don't have on here. Okay, and you're using parentheses because it has to deal with infinity. So your range, same thing. So then same thing, you have negative infinity sign to infinity. Because the graph continues on forever in both directions. It has no breaks, no jumps. Domain and range of this guy. Okay. This is a linear equation. Oh, I like how I pointed with my hand. This is a linear equation. This is an exponential equation. How do you know that? Because the x is an exponent, so it's going to be exponential. Okay. So let's look at this. 3 times 5 to the x. Let's see if it lets me do this. Y equals 3 times 5 raised to the x power. Hey, there it is. Oh, look, they intersect. That's kind of fun. Okay. That means they're equal at that one point. I didn't know they were going to intersect. That's fun. Okay. So anyways, exponential. So we are continuing up forever and ever and ever and ever and ever and ever and ever. So our range, I guess let's do domain first. Sorry, domain first. So focus on your lowest x value. Well, it's continuing this way forever. So my lowest x value is going to be negative infinity. And then it's also continuing up forever. So my domain is going to be negative infinity to infinity, which is what it will be for most exponential graphs. They'll continue forever on in both directions when you're looking at the domain. I'll have to go back to the homework. There it is. Okay, so domain, negative infinity, it continues on forever in that direction, and then it continues on forever to the right. Okay, and then range, let's go back and look at the range. So your lowest y value, you have what's called an asymptote. Every exponential equation has an asymptote. It means it's a horizontal asymptote, so it goes, it's like this, left to right. It doesn't go up and down. That's a vertical one. It's a horizontal asymptote, so it's horizontal, left to right. So every exponential graph has one. A lot of them have it at 0. We actually have a horizontal asymptote at y equals 0, which is the x-axis. Okay, so we're going to get closer and closer and closer to touching the x-axis, but we never actually will. So, homework. Your range, the lowest it's going to get is 0 with a parentheses because we're never actually going to get to 0. We're just going to get really close. And then we continue up forever and ever and ever. So to infinity. There you go. Okay. The elements, you could also figure that out, hold on, without graphing it if you wanted to. I could substitute any value in for x, and I will never get 0, and I will never get a negative number. This is a little sideways tangent, so you don't have to watch this if you want to. We're going to talk about exponentials for a second. Let me pull up a Word document. Just a new one. Okay, so y equals 3 times 5 to the x power. Make this all a little bigger because this is all we're doing on this page. Okay. Get rid of exponents. So I'm going to put it in a table. I have x and I have y. Okay. So I don't know. Let's just start with 0. I substitute 0 in for x. So that's going to be 5 raised to the 0 power. Anything raised to the 0 power, 1. So that's going to be 5 to the 0 power is 1. So 3 times 1 is 3. Okay, and obviously if I put in positive numbers, it's going to be positive. 5 to the first power is 5 times 3 is 15. Okay, 5 to the second power, 5 times 5 is 25 times 3, 75. And we're multiplying by 5 each time. What if, I'm going to do it. I don't know if I should do it, but I'm going to do it anyway. What if I put in a negative number? Does anyone remember what it means, what you do when you have a negative exponent? Hold on. Insert text box. Okay. So when you have a negative exponent, what do you do? So, let's make my writing a little bigger, at least. Okay, so then I have y equals 3 times 5. But I'm raising it to the negative 1 power. Okay, there's actually, where do I have it? Here it is. Understanding rules of exponentials. I should probably just share this with you guys at some point. I mean, we'll go over it all at some point. Okay, here we go. A number with a negative exponent is the reciprocal of the number to the corresponding positive exponent. What does that mean? This is what this means. So like 2 raised to the negative third power, you turn it into a fraction. So now you have 1 over 2 to the positive third power, which is 8, because 2 times 2 is 4 times 2 is 8. Okay. We should just do this in class. Maybe we'll do it after the test. So what that means is I'm going to have 3, and so I'm turning this into a fraction, times, sorry, equation, fraction, this fraction, over 1, and then you have 5 Oh, is it gonna let me? Probably not. Raised to the first? Nope. Maybe I have to insert equation. Should be fine. 1 over 5, and then that has to be raised. What if I type it in? Raised to the first power. That doesn't look how I want it to look. Okay, well, okay, so 1 over 5 to now it's, instead of -1, now it's +1. I should put parentheses back around this guy. Not just there, around the whole thing, please. There it is. Parentheses. Okay. 5 to the first power is just 5. So then you have 3 times 1/5, which is just so this is 3/5. All right, let's do a bigger negative number. Let's do -5. Okay. So you would do what? Y equals 3 times 5, and then we're raising that to the -5th power, -5. Okay. So when you have a negative exponent, you turn it into a fraction. 3 times, insert equation, fraction, that fraction. 1 over 5, and then the 5 that's in your denominator, you raise that to the +5th power. I don't know how to do on here. Hold on, I'm scrolling real quick. No, okay. So then do your exponent first. So 5 to the 5th power, 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5 is 1,325. So it's equal to 3 times 1, insert equation, fraction, this fraction. 1 over, at least I think that's right. Let me double check. 625 times 5. Yeah, 3,000. Now I can't remember what I said. Is that what I said? Probably not. That's what it is. 5 to the 5th power is 3,125. So then this is going to be a really small fraction, because then so our answer is going to be, so then that equals, so you multiply straight across 3, so then that's 3 over 3,125, which you actually can't reduce that. So that is the fraction that you're left with. So it's 3 over 3,125. Actually, let me turn it into a fraction. Insert, write it like it, write a better fraction of that. Okay, so it's 3 over 3,120. There we go. Okay, so the point of all this, you're like, what was the point, Miss Bailey? I'm like, I don't know. Was to teach you about negative exponents, but also to show you that no matter what I substitute in for x, even if it's a negative number, I'm just going to get a smaller and smaller and smaller fraction. So if I substitute in a huge negative number, like -100, I'm not going to do it. But it would just give me a really small, incredibly small fraction, but still would not be equal to 0. Okay. Oh, here, let's make it up. There we go. Ooh, there we go. Negative 100. Bothering me. All right. So we're just proving that no matter what you substitute in for x, you will never get 0 or a negative number. It'll just get incredibly small fractions. Okay. Anyways, number 8. The elements in the table define the entire function. Okay. So this is like how they give us the braces, the face brackets. They're saying 1 and 9, 2, 98, 3, 987, 4, 9,876. Those are the only values of our function. Nothing in between, just those. So then your domain, you would just, hold on. So domain, you're just going to make your own little brackets, space brackets, and then rewrite their x values. So 1, 2, 3, 4. We're supposed to be saying if these are functions or not? Nope. Okay. This one is a function because one x value corresponds to only one y value. And then for range, face bracket, or brace, whatever you call it, and then you just rewrite all the y values in order. 9, 98, 987, 9876. Face bracket. Domain range. Okay. Here we go. The distance out. Determine the domain range and then determine whether or not the domain and the range. Oh, so that's a terrible way of saying that. So really wants us to say which one would be our, if we were graphing this or making a table, which one would be our x value, which is our independent value. Hello. And which one would be our y value. Joe, come say hi. No, he wants to go on a WALK. Not yet. Not yet. So the distance a person is from the ground related to time as they ride a Ferris wheel. My Lobo, no, not yet. Don't feel sorry for when we went out like it's only been like 3.5 hours. It's not that long. Not that long. Here. Come here. No, come up here. Come here. Jump. You're just sitting here crying at me. Ready? Oh boy. Just sit on. Okay. Stop crying at me. Stop it. The distance a person is from the ground related to time as they ride a Ferris wheel. Okay, so let's think about this. You're at the carnival riding a Ferris wheel. At time 0, you have not left the ground, right? But then you get on the ride, and so after 30 seconds, we'll just do minutes because that's easier. After a minute, you're like here. Oh, I mirrored. After a minute, you're like here. No. I don't know which way makes sense. But the ride starts going up, right? As more time goes by, you get higher and higher up. And then at some point in time, after 5 minutes, you get to the top, and then you start going down. Oh, see, I should have done it this way. Yeah, that would make more sense. So you start going up, then you get to the top, and then you're going back down. So time is going to be the domain, the independent value there, and then depending on how much time has passed, that's how far up you are on the Ferris wheel. Okay? So this is going to be a function because, so let's see, a time equals, I don't know, let's say 1 minute, you're right here. And that's the only spot, right? After 1 minute, you're right here. After 2 minutes, you're right here. After 3 minutes, you're here. 4 minutes, you're here. 5 minutes, you're here. So for each minute, there's a corresponding distance, but Yeah, there's only one output for every input on that. Like, at 1 minute, I'm only here. I'm nowhere else. After 2 minutes, I'm only here. I'm nowhere else. So it is a function. Okay. The amount of daylight during a day throughout the calendar year. So think of like daylight savings and stuff like that. Summer versus winter. Our days get longer and shorter, right? That is going to be a function. Depending on what day of the year. So your independent variable is going to be the days of the year. Your dependent variable is going to be daylight. So amount of daylight would be your range, and then the days of the year would be your domain. Okay, so for every day, the day is a certain amount of time. For every day, there's a certain amount of daylight. Right? In summer, we're going to have more daylight, and winter, we have less daylight. So for every single day of the year, there's a certain amount of daylight for that day. So it is a function. The value of a Volkswagen Bug convertible from time of purchase in 1978 until now. Okay, so that is also going to be a function. The value is going. What would it be going at? Are those are really popular? I don't know. I don't know enough about cars, but the value is either going to be going up or down based on how much time has passed. I don't know. But anyway, so the value of the car, as more time passes, the value of the car is going to change. So it is a function. I could graph that and it would be a function. A person's name and their phone number. It's a weird one. A person's name and their phone number. Oh, that's a weird one. That is not a function. My name is Miss Bailey, but there are other people with that name that have a different phone number than I do, right? Like if your name is, we don't have anyone with the same name. If your name is Matt, like you have your own phone number, right? But then there are so many other Matts in the world that have different phone numbers than you. So your independent would be the name, your dependent would be the phone number, but it would not be a function because there are so many Matts in the world, there are so many Miss Baileys in the world that we all have different phone numbers. So it is not a function. Not function. The stadium in which a football player is playing related to the outcome of the game. The stadium in which a football player is playing related to the outcome of a game. It's not a function. How do I explain why? Let me get back to you on that one. It's not a function. Maybe one of you can come up with a good explanation for why it's not a function. I can't think of a good way to explain it. Let me think. All right, and then 14, you're describing the function of the graph. So where it's increasing, decreasing, the min and the max, the domain and range. We've done that a lot. I'm going to let you do it. I have other homework help videos where I do that. 15. Hope has been tracking the progress of her family as they travel. Okay, you have to get down now. Or you can sit there without me holding you. Okay. She knows they are driving 78 miles per hour, and she has created a function. D of t equals 78t. So this is very similar to the homework problem from Thursday, where she made a function for how far she walked. So now instead of walking, they're doing driving. So what would Hope be attempting to find if she writes d of 4 equals 78 times 4? Okay, so she is substituting 4 in for t. it hours, right? So how far they drive in 4 hours. And then she could multiply 78 times 4, and that would tell her how far they have driven in 4 hours. What would the expression d of t equals 450 mean in this situation? That means that's the distance. So they have driven 450 miles. That's what that means. We don't know how long it took. We could figure it out, but d of t means the distance equals 450 miles. Ooh. What would the expression d of 3.5 mean? Ooh, they gave you a decimal. I'm giving you think time. What does that mean? It means 3.5 hours. So 3.5 hours. Oh, I forgot. How far have they driven? Right, so it's been 3.5 hours. How far have they driven? So you substitute 3.5. Sir. You substitute 3.5 in for t and then solve. How could Hope use the function to find the time it would take to travel 800 miles? (800 miles is the distance, so 800 equals 78 t, and then you would solve for t. By dividing by 78, 800 divided by 78. It's like 10.2, we'll round it up. Hours. So you can substitute 800 in for the distance, and then you would solve for the time. Where does f of x equal g of x? Where they intersect. So -5, -6, -7, -8, 5, and 0, -4. So wherever they intersect is when they're equal. What is g of 0 plus f of 0? So your first thing is to figure out, well, what is g of 0? When x equals 0, what's the other value? And we're looking at the g of x line. So when x equals 0, it's -4. Okay, f of 0. So now we're looking at the other line. When x equals 0, it's also -4. So what is -4 g of 0 plus -4? -8. Okay, see on what intervals, wait, we haven't really done this. Oh well, is g of x greater than f of x? So when is g of x greater? So whenever we're looking at the y values. So it's greater here because it's higher up. So it's greater here, and then it's lower, it's lower, it's lower, it's lower, it's lower, and then it's also greater here. So, ooh. -infinity, right? Because they're both extending forever this way. So -infinity to 5. No, sorry, we're looking at x values. To -7. No, -8. -8. Let's see. So g of x is greater from -infinity all the way to whenever x equals, is it -8? Yeah, to -8. And then it's lower. See how f of x is, the y values of f of x are higher than the g values. Okay. But then when we get here, all of a sudden g of x is greater again. It's higher up on the y-axis. So that one, and then in parentheses, when x is 0, that's when they're the same. But then after that, g of x is greater again, all the way to infinity. There you go. And then D, G of -8. So what is G of -8? When x equals -8, what is G? Oh, that's 5. So, and then F of -8 equals, oh, they intersect there, so they equal the same thing, also equals 5. So then 5 plus 5 equals 10. So 10. Woo! That was long. I'm tired.